Hello, everyone. Thank you for joining us tonight on our 10th episode of second season of our BA Day Afterwork Talk podcast. And today we have a really interesting topic. We'll talk about how we can really use AI in real life applications, not in just creating some images and writing some emails. And I have a great guest tonight, Dr. Hanna Richta. But first of all, let me just remind you about me, your host. I'm Oleksandr Moskalyuk. Rainer can also join us, but maybe I will be alone or he will join us later. Both me and you, me and Rainer, we have more than 50 years of experience in IT, and we always try to support our guests and make our conversation more interesting and tell you some real life examples of what we can do in business analysis with technology, with new ideas, and everything else. Also, we're really grateful to our sponsors, Deutsche Telekom for supporting our project and our conference. Also, IREB, IBO, and Mosventa. Please don't forget to buy your tickets to our European Day conference in May, because we will have a lot of interesting speakers, workshops, and one of them will be Hanna. So, Hanna, happy to have you. Please tell a few words about yourself.
Thank you for having me. Good evening, everybody. Thank you for joining us. Yes, who am I? I'm the head of algorithms for operations at DB InfraGO. DB InfraGO is the network provider of Deutsche Bahn. So everything that's connected to tracks and signals and every other installations that is necessary to make railway possible in Germany is the part of DB InfraGO. So in operations, our job is to support the people who keep the trains running right now with good to help them make good decisions to have the trains as punctual as possible. For this, I have two teams in my department. One is building an assistance system for train drivers. So that's not the topic that we talk today about, but the other team builds a assistance system for dispatchers. And today we talk about the dispatching assistant that my team built during the last, about 10 years. So from my background, before I joined DB InfraGO, I was for nearly exactly 9 years at DB Cargo. There I had different roles, including lean management, IT management. I built a data science team and I led a project where we built ETA prognosis for freight trains. From my background, I'm an economist and I live in the Frankfurt Rhine-Main area. So that's me.
Yeah, thank you very much. And again, happy to have you tonight. And so our topic, and the main question is, okay, AI. I know that human people used trains for more than 100 years. There was no AI, and I know that Deutsche Bahn was always the standard of how trains should work and how schedules should be just working of trains. And what has changed?
What has changed? Well, we came a long way during the last more than 100 years from the steam locos to the electric locos, and now to this still locos, still rails and wheels on rails. But of course, we are using data to make everything more efficient. We have so many use cases for IT applications or intelligent IT applications like predictive maintenance for our infrastructure as well as for our trains. We have the all the scheduling classical optimization problems, and we have the newer opportunities like using dispatching assistance in real time, where we can use several methods from the field of AI to tell our dispatchers which train should go first, which train should go second, where we should go do an overtaking, where should a train wait. And all this is possible by this next step, the digitization.
Okay, yeah, I know that you have a great presentation, yeah, prepared with a lot of illustrations. So please share it. So I will stop sharing and let's
Okay.
dive, yeah,
Yeah,
into.
let's go. Let's have a look. I should start. Wait, we tried it. I
Yeah,
first start the
just
presentation and then I share my screen. Um, there we go. Hmm. Well, and one click more.
yeah. And
So
in few seconds we will see it, yeah, on our screens. Yep, it's here.
yeah, you should see my screen and there shouldn't be too many artifacts or something like this.
Yeah,
Okay.
it's yeah, clear and yeah, and perfect. So what is automatic dispatching assistance?
Yeah, our automatic dispatching assistance ADA is like an co-pilot for the dispatchers. So I start with some challenges and objectives, and then I show you what it is. So what is our initial situation? We have mobility transition. That's the big political term. We want to shift from road to rail. And this means we want to have more people and especially also more goods being moved on rail. Um, but how can we do this? Having more traffic on the tracks without having more infrastructure means congestions, traffic jams, or can mean, because we have to use our infrastructure as good as possible and as intelligent as possible. And here comes the human intelligence as well as the artificial intelligence into play. Because building new tracks is very expensive and takes a long time. You have to go, if you want to build new tracks, you have to go through all these political discussions with the people living next to the tracks. You have to find the money, you have to find the right construction companies. It takes 10 years or more to build a new track. To build some IT, it's not completely inexpensive, but compared to what it costs to build new tracks, it's really cheap in comparison. So we want to use this IT and the artificial intelligence that we built to utilize our infrastructure as good as possible. So here comes our dispatching assistant. We want to improve the punctuality and we want to support our dispatchers. So maybe I should give a short definition. What are dispatchers? What are they doing? I guess most of you do know the air traffic controllers. They sit at a big screen, they see all the trains moving around in their area, and they have to decide which train should go where, in which sequence, so that every train is as punctual as possible. And yes, usually you have a schedule where you know where the trains should go. But as soon as there are disruptions in the operations, you can yeah, you have to make decisions. You have to make plans and find a way to get back to the schedule as quick as possible. And here we help. Um, Besides this, we we help by giving dispatching recommendations. So our dispatchers are still the people who are in charge. So we keep the human in the loop. That's if you talk about AI, it's always a big discussion. Should it be completely automated or should the human be in the loop? We say the human should be in the loop, at least for the next, I don't know, probably many years, because it's usually a human plus an assistant system is more intelligence than the human or the assistant system by themselves. So we give recommendations. And our recommendations, that's the next big point, have to be non-discriminatory. So what does this mean? Well, we have only one big company that owns rail tracks in Germany. That's DB InfraGO. But we have some European regulations and German regulations that we have to allow every company to use this tracks if they meet our standards. And if they pay for their slot on our tracks, they have to get this track. So we are not allowed, just because we are part of the DB group, to say, well, our DB ICE should go first, and every other train should wait. Maybe I don't know, Flixtrain or Nordwestbahn or whoever. No, no. Everybody who pays the same has the same right of way in their slot, and we have to ensure that we keep this promise, and that our dispatching assistant doesn't do anything that goes another way. So, and this is not just a theory or law, but our regulators do check this. They talk. We have tough discussions with our regulators, and they want to know how we ensure that we don't discriminate other trains, especially since we are part of the DB group. So how do we achieve this? We have this assistant with an optimization in the core. So mathematical optimization is discrimination free. We say, well, this is our target function. We want to minimize delay, and well, nobody can be against minimizing delay on trains. So if one train has to wait, we can say, yeah, well, this is because every other train will be more punctual by this. That's fine. Also for our regulators and for all our customers, as far as I know. Yet, the mathematical optimization wouldn't be quick enough to find a solution on time, because the trains are right now running. And if you go over the switch point, you can't change it anymore. So if it takes 10 minutes or half an hour to calculate your optimization, then you say, well, the train was here 5 minutes ago. We can't change it. So we have usually 1 minute to do the calculation. And we speed up the optimization by giving the optimization some hints that are based on AI inputs. I will tell you some more about this later, but that's our concept, and that's the core of our assistance.
So,
So,
mhm.
most
So,
important, how does it look like? Okay, how does it look like? On the right side, you see the typical dispatcher workplace. In this case, it's the Berlin. They have this on the right side of this place. They have 8 big screens. That's the dispatching system, and it's like playing a real-time game with keeping an eye on each of these 8 screens at the same time. That's quite a challenge, and I've a big respect for all the people who are doing this job.
yeah, it's even more cool than playing on with on the market,
Yeah,
the stock market, with stocks.
yeah. Right. And then you have on the left side of the workplace 2 more screens. And these are screens for additional applications. Goes from email to the shift diary to some news pages. If there are people on the tracks, they get police news or something like this. And on this screen is also our ADA-PMB, our automated dispatching assistant. In the future, we hope to integrate it right into the dispatching system, but changing the dispatching system takes maybe 2 more years. That's quite a big step. And we have to prove that we are worth to get into it before we do the integration. So we are right now in the pilot testing phase on the extra screen. So what does it look like to do this dispatching recommendations? We have 4 kinds of dispatching recommendations. This is the overtaking, the track change, the crossover, and the threading. All of the dispatching recommendations to have their own symbol, like an icon, so the people see what they should do. And then they have the location. It's in the upper right, where it should be, where this dispatching should happen. This is usually this 3 or 2 letter symbol. And in the a little bit gray besides this is the name of this location in clear text. Because our dispatchers, they work quick and they know their area, they just use these 3 letter codes. People like me do need FFS is, oh yeah, Frankfurt Main Süd. Okay, so you see it's a little bit fake. We have the Berlin workplace and we have recommendations from Frankfurt, but that's for illustration purpose. So then you have the numbers of the trains. You have, for example, on the overtaking, you have an ICA and you have, I guess nobody from outside the railroad company knows this, TFZF, the blue one. This is a train that is just a loco going from one place to another. Maybe it's a freight loco getting the next freight train job. And here the overtaking says let the ICE go first and let the loco that's going alone wait because there are much more people in the ICE. And besides this, usually the people trains, so the ICEs, have a priority over freight trains. So here we do the overtaking. The track change is quite the same like overtaking, but we are using parallel tracks, so we can utilize our infrastructure. The crossover is like, from driving in a car or on a bike or whatever, you get a crossing and one has to wait, the other one is allowed to go. And the last one is the threading. You have which train should go first, which one should go second on a one-track connection. Yeah, besides this, you see in the middle bottom of the screen the minutes left to do the dispatching. So you see it's between 7 minutes 31 and 2 minutes something. That's the usual time frame for the decision making of the dispatchers. It's so we don't look ahead to like 4 hours or something like this. We are just in the next 10-15 minutes. That's our time span that we try to give recommendations. And our users tell us, yeah, that's absolutely okay to do it within this short time span because traffic situations are chaotic and they change, and it's no use to make a plan for the next hours in dispatching. You have to solve the problem right when it occurs. So, yeah.
Yeah, it looks simple and very complicating. Yeah, complicating at the same time. Yeah, because you have simple rules, but number of this, yeah, makes it really complicated.
Yeah, and
Complicated, yeah.
every trains are interconnected. So if you do one dispatching, you can have a problem 2 hours later somewhere else where the train is
Yeah, just waits for other
someone
moving
else.
or blocks, yeah, somebody.
Yeah, so
Okay, but looks cool.
yeah, but how does it work? Let's take a look. We we have this still easy 4-step schema to do our to come up with our recommendations. First one is the input data. Okay, we could say it's step 0 because we are not the input data provider, but everybody asks us, where do we get the input data from? It's the original data from our dispatching centers. So everything the dispatchers see on their screens, you remember the 8 screens? Everything the people see on these screens will appear in our ADA-PMB. So this is the infrastructure, the availability, the timetable, and the train data, so the train position. Besides, yeah, one point to mention, everything that is not in the dispatching system is also not in ADA-PMB. So if someone forgets to enter a construction site or something like this, we can't work with this. Fortunately, our dispatchers are kind of generous and tell us, okay, well, if we don't see it on our screen, how should your computer know it? Okay, fair enough. So we get all this input data and then we run a pre-process. This pre-process has two main points. The first one is we build an optimization model, classical mathematical model like most of us know from university or maybe even high school, where you have a target function, something you want to optimize, and many side conditions that you need to meet. This is built on the fly, and if the infrastructure changes or if a timetable changes, this is automatically built into the into the mathematical model in the pre-process. So our system is quite flexible to changes in the situation, and is can be theoretically easy implemented in other locations. The second part of the pre-process is the one that's interesting in the AI context, because here we create the hints to accelerate the optimization. We use for this some heuristics and some machine learning. I will come on the next page to some details about this. Then we feed everything that we calculated, the model, the hints, we put everything into an optimizer. And we use a commercial optimizer, in this case, Gorobi. This is because optimization is such a general problem that's solved by specialized companies. We don't need to build this. We don't have to invent the wheel another time. And those commercial optimizers, it's Gorobi. There's another one by, for example, IBM. They're so much faster than everything you get and everything you can build for your own. So we just use the optimizer. And then comes the interesting part. Then we transform the optimization, all the mathematical models, the variables, into these nice tiles, these nice hints that we can show the people to tell them what to do. So that's the third part, or the part 4 if you count the input data. Okay, let's go to the AI. So we use a broad definition of AI. This is according to our regulators. The EU Data Act was the appendix changed a little bit, but usually this is all considered to be AI. And yeah, what we don't use is the generative AI. We use the machine learning, the heuristics, and the optimization. Optimization, okay, we talked about it. That's the core. The heuristics, where there are some rule-based systems for the preparation and the plausibility checks of the input data. That's not very special, not very intelligent. More intelligent and more interesting is the heuristics based on the previous solution. So if you run it each minute, the optimization, the whole situation doesn't change so much. You don't, if you I gave some hints. We have the Berlin, we have some area in Berlin, we have some area in Frankfurt. If you look from 1 minute to the next one, you haven't beamed 50 new trains into this area. This is just a gradually evolving process of trains coming into an area or moving out of an area. So we can use a big part, but not everything of the previous solution of the optimization to feed it into the new one. So the optimization has not to invent everything again and again and again. So the next one is also interesting, the relevant inputs. Maybe we have some um, ways a train could go that is makes absolutely no sense from a practical point of view. So we can reduce the model by only allowing the useful connections. And last but not least, we have some additional heuristics like having the Dijkstra algorithm for finding ways and having the shortest connection as minimum time for travel. We got some good improvements by introducing this minimum times for travel, so we can tell the optimizer, well, you can't assume that the train goes faster than this time. And so you could cut down the solution space again. That's yeah, so the classical heuristical approaches do a good job in reducing the optimization time. But then we also added the machine learning. We did it for two specific cases. We tried it for two cases. One is the speed profiles of the train, and yeah, my people call it the X variables because it's if you have the graph, you go in time on the X axis, I guess. And by introducing them, we could speed up by 10% the calculation time again. Another one was the order swap variable, Z variable. Um, we got really good predictions, like accuracies of 99% or 98%, but we saw that they don't increase the speed of the optimization. So that's also part of the story. We don't use everything that we invent. We use just that what helps us to speed up our optimization. So we dropped this approach. Also, we got really, really good accuracy measures. Yeah, that's research at its best what we are doing sometimes. That's the most interesting times usually. So, and then to track everything and to optimize our models further, we have business analytics. We have a big Power BI platform to track our recommendations, to track our model times, to track the accuracies, to track the traffic situations, and so on. So we track everything. We have this Power BI to keep an eye on the performance of our models and of our system. Because without this analytics, you're going blind. You can't improve what you can't measure. And we have so many small parts that we want to improve. That's important, and it's also important to have it easily accessible on an BI system like this, because if you run all the statistical analysis again and again, you quickly end up doing the work again and again, and you don't have time to think about solutions because you just do the number crunching. So this is a really helpful part of our system as well. So last part, the piloting. I guess maybe the most interesting. Oh, you have a
Yeah,
question?
it's always interesting to see how it works. Yeah, because the theory is okay. Yeah, it's interesting, but yeah. So how it works?
Yeah, how it works and where do we apply it?
Mm-hmm.
Yeah, we started in 2020, so 4 years ago, in Berlin, in a very simple situation, because it's only for the S-Bahn, the regional trains. They they have some very nice features for starting approach like ours, because they go always the same speed. They don't want to do the overtakings. Um, but there are a lot of threading, some track change, and some turnaround situations. So we can support this. And then our next step was to go to Frankfurt, um, 2002, in the end of 2002, November, 2022, of course, sorry. And here we started between Hanau and Frankfurt main station. Here, just to tell you what a great job my team did. When we started the model from Berlin for the first time for the Frankfurt area, the calculation time was 30 minutes or above. So we did all the optimization and the AI and the heuristics to bring it down to usually below 1 minute. So from over 30 minutes to usually below 1 minute. So this is the AI and or this whole mix what we do, and we are still improving. So here this was the mixed traffic problem. So we have the long distance trains, we have regional trains, we have freight trains. Yeah, we have everything here. But it's, you see, this is still a small area. This is also, to be honest, with all the technique and all the AI and optimizations to make the optimization as quick as possible, we still are only able to do these areas like this one. Yet it's better than nothing. And we have another technique introduced in June 23. So about half a year later, there we connected to optimization runs. So we feed the results of the first one into the other one. If you go from Hanau to Frankfurt Airport, this is here. You get the optimization result for the Hanau train goes to this second instance of the optimization, and so you can get a larger area by connecting the pieces like a big puzzle. Um, so then we started another one. This was in April 23. This was just between Stuttgart and Ploching, because we have here this green new track, and you see the old gray track. And yeah, but they go all over the blue track between Ploching and to Stuttgart. So there's a lot of threading decisions to make, and ADA-PMB does help here in these blue tracks. So and then the next big step was to go to Munich. Here we are on the Munich S-Bahn Stammstrecke. That's the core line of the regional trains. So you see all the different colored lines in this blue square. This is all the regional train lines going on this central part of Munich. And here we had to increase the time that we look ahead to 30 minutes, because you can't change the sequence of the trains on this very dense central area. So you have to make a wise decision before they enter this blue box. And here we help, and here we managed to improve our models so that we are able to look 30 minutes into the future and do good or to provide good recommendations. And then we even increased this by taking these two branches, like the S4 to Geltendorf and the S1 to the airport. And finally, by all the improvements that we made, we were able to increase the area that we look at in Berlin. So we had this blue one here, this one, and now we have this one as well. And all the improvements that we made helped us to do these additional tracks. Not much, but you see, that's what the optimization and the increase of speed of optimization makes. And the last one, additionally, we started in the Northwest German area around Osnabrück. This is because here you have the red line is the border to the Netherlands, and some border crossings were closed due to construction work. There was a very dense traffic around this area last winter, and we went there with ADA-PMB to support our dispatchers in these special situations. And yeah, of course, we keep it running to learn more and to use it even after the constructions. So that's what we do. And here's some statistics. It looks right, I know, but this is our measurement. How effective is ADA-PMB? It's very hard to get the effects, but we did it for the Frankfurt-Hanau area. And here we investigated about 10,000 trains or not trains, recommendations. So the 10,000 recommendations we saw for threading, because this is the one that is really good to investigate, because you know train A should go before train B, or train B goes before train A. So if you recommend train A should go before train B, you can say here, yes, this is the recommendation. Or if you see the train B goes first, no, the recommendation was not used by the dispatcher. So we saw first in more than 7,000 times the recommendations were used. To be scientific precise, we can't say that this was always because of ADA-PMB. Maybe the people were just smart and found by themselves the solution that was according to the ADA-PMB solution. But well, in 70% of the cases, the dispatchers did what ADA-PMB recommended. So we had a control group of the other 3,000 recommendations, and we could analyze what is the delay of the trains, of both trains combined, if you use the order that is recommended by ADA-PMB, and what is the delay of both trains combined if you don't use this. And we saw if you use the ADA-PMB recommendation, you win 100 seconds. 100 seconds combined. So even if one train has to wait for 30 seconds, that means the other one has 130 seconds won to get a combined of 100 seconds improvement. And we did this for several locations, for several spans. So we have the blue one, this is just the next station. The yellow one is a few stations. The third one is even some more stations ahead. And then you have this, I don't know, pink or something that says in the whole wide range for the whole Frankfurt area. So, but overall, we say mostly 100 seconds. That's quite good. If you can do it with every recommendation 100 seconds, it can help you to change things. So, and finally, I have some voices of our users, 2 minutes, I guess. I haven't them in my living room, but I have them on a video. So I hope it will work. This is none of our users, this is my boss, but after her, there will be our users. So let's go.
ADA-PMB erzeugt Dispositionsempfehlungen, die unsere Disponentinnen und Disponenten in ihrem stressigen Arbeitsalltag unterstützen und entlasten sollen.
Die Einführung von ADA-PMB bei uns in Karlsruhe, kurz und knapp, lief reibungslos.
Ich glaube, die Neugier hat bei den meisten überwogen und viele haben sich direkt von Anfang an darauf eingelassen.
Was kann die KI? Hilft sie uns wirklich? Unterstützt sie uns wirklich? Und die ersten Schritte zeigen, ja, sie unterstützt uns. Sowohl die Neueinsteiger als auch Quereinsteiger, die aus völlig fremden Branchen kommen. Für die ist das eine wertvolle Hilfestellung.
Auch erfahrene Disponenten profitieren von ADA-PMB, weil ihr Bauchgefühl mathematisch bestätigt wird und sie damit sicher sein können, dass ihre Dispositionsentscheidung die optimale ist.
In größeren Störungslagen ist es häufig so, dass man den Blick fürs große Ganze verliert. ADA-PMB hilft dann dabei, auch das gesamte Netz zu betrachten, dadurch, dass die Dispositionshinweise auch für Bereiche außerhalb des Störungsbereichs gemacht werden.
Obwohl das Netz der BZS-Bahn Berlin relativ klein ist, haben wir dennoch über 3500 Zugfahrten pro Tag. Da ist das schon enorm hilfreich, wenn ADA-PMB uns dabei unterstützt, den Überblick zu behalten.
ADA-PMB unterstützt mich dabei, auch wieder aufs Wesentliche mich zu konzentrieren, die Reihenfolge der Züge zu regeln, die Pünktlichkeit im Blick zu behalten und trotzdem dem gestiegenen Informationsbedarf oder auch den gestiegenen Anforderungen gerecht zu werden. Dann lenkt ADA-PMB im richtigen Moment meine Aufmerksamkeit wieder auf die Hauptstrecke, um dort notwendige Maßnahmen zu ergreifen.
Positiv überrascht hat mich, dass die Bedienbarkeit von ADA-PMB sehr einfach ist.
Die schiere Menge an Daten, die ADA-PMB verarbeitet, um zu einer Dispo-Empfehlung zu kommen, die ist sehr beeindruckend. Schlussendlich ist es ja das, was wir intuitiv als Menschen auch tun. Wir betrachten das Gesamtsystem und kommen zu einer Entscheidung. Ob wir das allerdings über Stunden als Menschen dann immer leisten können.
Die Technik wird den Menschen nie komplett verdrängen oder ersetzen. Insbesondere in der Disposition kann sie immer nur unterstützen.
Ohne Disposition geht's nicht. Und mit dem Mensch allein werden die gestiegenen Anforderungen auch nicht zu bewältigen sein. Deswegen brauchen wir solche Systeme. Ich bin dafür.
This is the voices of our users. And thank you. We have plenty of time for questions, I guess.
Yeah, and some discussion, I think, yeah, if you don't mind. So it's first of all, it's great to see, you have feedback, direct feedback from your users, and you can see if the solution really works. I think it's the best. Yeah, and also, from one point of view, 100 seconds is not too much. Yeah, not much, just small amount. But we're talking about real life trains. It's huge. There is a lot of people, and it's really risky to change anything there. And just having this, I think there is AI is just second or third level of support, because always people just trying to make the best decision, to protect the decision. And when you have even there, when people saw twice, 3 times before they use AI and they see improvement, it's great. And I think it's when you start using it on wider network, the results should be much more in numbers.
Yes. Yeah, we will increase this further. We have new pilot areas in discussion. I can't talk about them until we have started the pilots, but we have new areas and 100 seconds. Yes, that doesn't sound much, but if you imagine that we have maybe 500 recommendations for one area per day already today, and you get maybe 70% of them are followed. So you have 700 minutes, 700 seconds times 5. So you have a huge amount of time in the small pieces, and you get yeah, you won't make it won't help you to catch your plane if your train has 2 hours delay. Yeah, sorry. But it helps to make the system more stable. If you have take out the small delays, or if you decrease this delays, the system will be more stable, and maybe by this we reduce the chances that there will be a train with a 2 hour delay or something, and then it helps you even to catch your plane.
Yeah. Dominique, you have a question?
Yes, hello. Thank you for the presentation, Anna. My name is Dominic, and I work for Austrian Railways, and we're building exactly the same thing, ÖBB Infra. So my question is, I saw a presentation from DB 1 year, 2023, were on the Ben Holiday event. I don't know if you were there in Vienna, where it was shown that some AI startup did such conflict resolution across the whole network, not just small areas, but the whole network. Is this somehow related with your project or not?
No, not no.
Okay.
Interesting. I know there are some conflict resolution approaches. For example, the SBB is using a conflict resolution based approach for their dispatching assistance. And they do it for, I guess, quite big areas, but they are also limited for their calculation time. And yeah, would be interesting to see this startup. But,
Yeah, it was something with Insta something. Yeah, but that was just my one question. And the second question is, how do you measure your if the dispatcher took your advice or not? So do they have to press a button, or are you just kind of monitoring what happened? And if it's not the overtaking that you suggested, you say, okay, did not take it?
Yeah, we have this thumbs up and thumbs down button on our recommendations, but they are more for I used to say change management purpose. The people have the feeling like they can provide a direct feedback, but we don't get much of this feedback. It's like we looked at it last summer. We had nearly 100 thumbs up and 50 thumbs down. This is nothing
Okay.
compared to the number. So this is, and we talked to our dispatchers, and they told us, no, we don't have the time. If there's trouble, we have to fix the problem, and we don't have the time to click some stupid feedback.
Yeah.
Yeah,
I know this.
very blunt in their feedback regarding this. So we learn more by having people from our team spending time with the dispatchers and listening to them. So how do we get the information if the recommendation was followed or not? We have it only for this about 10,000 recommendation data set, because we went to the Frankfurt area, where we have the special situation that we got the exact data from the shunting, not from the shunting, from the switch point operation system for this Frankfurt area. So we know where the trains where the what the switches were and so on. So we have the detailed data on the microscopic infrastructure where the what happened. And we have it just for this Frankfurt area because for some reasons that nobody knows, we have for this switch operating station there, we get the data out of the system. So
Yeah.
it's, for many testings and so on, that's the area where we go. And we had a data science team from the DB group who took this for this 10,000 situations and did the calculations on this.
Okay. Yeah. But your only interface, as I understand, is the live data coming from the dispatching system like this, or I don't know. Is
Right,
it like this? Yeah.
Right. For our optimization and for what we do on the usual scale is it's only the latest system. But
Okay.
the
Yeah.
effects were not based on the latest system, but on this other data that were especially derived from the other systems to
Okay.
conduct effect analysis.
Because this what we came to conclusion is that we have to build a digital twin first of the current situation in real time, including many systems, not only the dispatching system, but many systems, which then provide a bigger picture that the operators might see, or the dispatchers might see, and then put this into this we call it advisory system.
Yeah.
I think you know Gerald Schinnagel. I don't know if you know him from Austria.
No.
He works on this system.
Yeah.
Okay, but thank you. Very interesting.
Thank you. Hope to see you on the conference and to talk.
Yes. Have you been in Berlin, InnoTrans? Because I was there at the.
No, no, I missed it.
Yeah.
I always say you should go there, and then I get other appointments. Well,
Yeah, in 2 years is again. No, 1.5 years. So we might see there. But maybe I talk with the guy, with Gerald. Maybe we can keep in touch regarding our approach versus your approach. It seems very similar.
yeah, would be great.
Yeah, Dominic, thank you. Yeah, thank you. It was interesting because often on our podcasts we talk more about business analysis tools, techniques, something like this. But now we can see real life how it works in real life. Because we from your presentation, it's real example how you build relationship with first of all with your stakeholders, understand their context. Because this example with some ups and down, it's understandable they won't use it because they don't have time for this. And you should get more information from different metrics, from different approaches, just to get real understanding what is going on, how it works. And often in different applications, it's very complicated to get some honest feedback from stakeholders because they are really busy. They don't have enough time just to explain you everything and tell you if it works or not. So you should just understand and analyze all the data you have, and the correct analysis gives you more information. But on the other hand, having such great feedback from stakeholders, it's another metric that it's useful. They want to use it, they like to use it, and it's really great, for any developer, just building this system, it's great to have such feedback. Anyway, you can see on the screen that Hannah will have a session during our conference. So just don't forget to book your ticket there, because we still have some early bird tickets, but they will end soon, and the price will rise a little bit. But anyway, we will be happy to see you at our conference, where Hannah will share more insights and more information about business analysis and how this ADA system works or other system works, and about this project. Do we have any other questions? Looks like not. So it's evening. Everybody wants to get to their own home. To dinner or something. So anyway, thank you for joining us. Don't forget to join to our conference at May. and we will have 2 days of workshops before and after conference sessions. And we have on 15th a lot of conference sessions, a lot of speakers from different countries, and we will be happy to see you there. Hannah, thank you very much. It was really interesting, and it's just real life example how it works, and I think a lot of people can even use it without understanding that they just traveling by train, and they can get to their flight only because the traffic was optimized by your AI.
Yeah, thank you for having me, and see you in May.
Yeah, see you in May. Bye, everyone.
Thank you. Bye.
Bye.
Bye bye.